right, so we'll get started. So today's live event is on Mill 3-Axis Premium High Performance CNC Surface Finishing. So we'll look at the part file that I have here. It's a basic 3D model, and I brought in sort of an assembly with the soft draws and the Kurt Weiss here. And we're just going to go through the same workflow as any other milling job. And I do that by going to the top and going to the CAM tab and starting a new job. And then I select my milling job type. I'm going to select milling for the job type, and I'm going to select my milling machine here. I'm just going to go with the BC3X mill. That's what it normally defaults to for any newer customers there. And BC here in the software program stands for BobCAD. So this is our BobCAD 3-axis milling machine, and it is a Fanuc-based G-code. You can look for your specific machine in the list here, and if you don't find your specific machine, you can always go to bobcadsupport.com and download a new post-processor, which will process the G-code for your specific machine here. All right, so once I select my machine, then I'll click on Stock Wizard down at the bottom. And it's going to ask for my workpiece. So I'm just selecting my finished 3D model here that I'm trying to get down to as my workpiece. Just click on it and then click on the next page. Then it's going to ask for my stock, whether it's a square piece of, a blank stock like this, or if I click on cylinder and hit calculate stock, it'll create a cylindrical shape like this. Or I can go to wireframe, extrude it from wireframe, or select a solid model, which could be really useful if you're working off of a casting. You can define the 3D model as you're casting and define it here so that you can machine just what's left over from the casting and avoid any air cutting. So I'm going to go here to cylinder, and I don't know the distance here from the bottom of the stock down to the soft jaws to make it look a little more realistic, so I can hold on to it a little bit there. So I'm going to figure out that length a little bit later here. I'm just going to leave it alone for now. I'm going to scroll down, and I'm going to go to the next page. And my last page here is my machine setup. This is my machine setup 1. It's taking a few seconds to refresh here. But the machine setup 1 page is going to be our work offset, our G54 work offset, where we're touching our tools off or using a probe to set as X0, Y0, Z0 for this milling job on the machine. So machine setup 1, a little bit further down, we have the coordinate system. I'm going to click on origin right here, and I'm going to click on top of the stock on the center as my G54 work offset. And then I'm going to scroll down to the bottom and click OK. All right. I don't know what this length is here, so I'm going to measure it. I'm going to go to the top and go to evaluate and go to measure 2. And I'm just going to click on this edge, and it will give me the distance in Z over here of 1 inch. All right. So I'm just going to add an inch to the stock so that it's down to the bottom of the soft jaws here. Make it look a little more realistic. I'm going to do that by going over to my CAM tree, right-clicking on stock, and clicking on stock wizard. And I'm going to add an extra inch to the height here. I'm just going to type in +1. So you can see I can do basic calculator functions. I can hit plus, minus, an asterisk to multiply, and a backslash to divide here. And then I'm going to click OK. Right here, in the CAM tree where it says stock, there's an arrow next to it. If I click on that arrow and expand the items there, we have a material library. So if I double click on where it says steel 1018, I double click there, we have different material groups over here. So whether I'm machining from carbon steel, aluminum, different types of plastic, we have feeds and speeds built into the software program for each material type. So these are some default settings in here for spindle RPM, cutting feed rate, those kinds of settings. We always recommend our customer contact their tooling manufacturer to make sure these numbers are dialed in for their specific tooling. All right, so I'm going to select cast aluminum and I'm going to click OK. So when I go through programming here, it's going to change my spindle RPM and cutting feed rates a little bit differently for cast aluminum. All right, and then we'll get into going through some of the 3-axis milling operations. Let me know if you guys have any questions so far in the comment section. We'll keep going here. Under the milling job, I right-click on Machine Setup 1, and we have all of our milling operations. Now, from the beginning of this year of 2026, we've gone through Mill Express, which includes mill drill hole, mill tap hole, counterbore operations, facing, and all of the 2-axis milling features, or 2.5-axis machining features here, which includes facing, profile rough, profile finish, pocketing, 2D engraving, all the 2D or 2.5-axis machining operations there, which is in Mill Express. Then we get into Mill 3-axis Standard and Mill 3-axis Pro. I'm just going to cover the basics on that really quickly, and then we'll get into the Mill 3-axis Premium toolpaths. So under Mill 3-axis, I select my geometry. I'm doing Mill 3-axis Standard / Pro for the roughing here. So I'm going to select the solid model as my geometry. And I'm not going to select a boundary because I want to machine everything here in blue with the roughing to get down to my workpiece here. So I'm going to click OK. Next page, it's going to ask my top of feature. So my top of feature is here, and I'm machining everything down from that level. And from that top of feature location, we have our feed plane set, our rapid plane, and our clearance plane. So the clearance plane of 1 inch is where the tool is going to retract, do a tool change maybe, go across for the clearance plane, and then it's going to rapid down to the rapid plane of 200 thousandths. It's going to rapid down to the feed plane of 100 thousandths. Then it will turn on the spindle, set the spindle command, the spindle speed, and set the feed rate, the plunge feed rate of plunging down into the material, and then your cutting feed rate to cut around from there. All right, and then our next page, we have all of our available operations here in the Mill 3-axis Standard and Mill 3-axis Pro. All right, so some of the basics here to recap from last time. We have our Z-level rough, our Z-level finish, following along the curved surfaces here. Planar, just going back and forth across the surfaces. Spiral, which will start at the center and spiral around like this. Radial, start at the center and sort of step over like this, back and forth. And 3-axis plunge rough, where we can plunge a tool down into the material to rough things out. So these first 6 milling operations are in the Mill 3-axis Standard, and then we get into the Mill 3-axis Pro operations. You can see in the Standard we have Z-level rough. In the Pro we have advanced Z-level rough. There's some options like a side roughing option in here, our high-speed machining option in the Pro. So it has all the same sort of features in the Z-level rough, plus more options to optimize the toolpath in the Pro. In the Standard, we have Z-level finish. In the Pro, we have advanced Z-level finish. In the Standard, we have planar. In the Pro, we have advanced planar. And then we have some other 3-axis finish operations like flatlands, where the tool or where the software will calculate all the flat areas, mill those out with a flat end mill. Equidistant is sort of our spiral toolpath here, giving us a better surface finish. Pencil to mill any fillets, and project curves, where I can project a 2D shape onto a 3D surface to do a 3D engraving operation. So I'm going to go down to the bottom. I'm going to get rid of our current operations here. I'm not doing a Z-level rough or a planar. I'm just going to go to advanced rough from my available operations and add that in with this down arrow. And then any operations I don't want, I can delete with a red X. If I have multiple operations here in this feature of my current operations, I can select one and sort them by moving them up or down with these arrows in the list of operations. All right, then I go to my next page. We set our work offset number, so I'm just leaving it as G54 for the work offset for these operations. Maybe if I have it fixtured, another piece of stock fixtured in another work offset, I could output for G55 or G56 here, different options like that. Next page, our standard UI and advanced UI. If you're interested in looking at more about the advanced user interface here, you can look at it in our previous webinar that we did on Mill 3-Axis Pro. I'm going through just some of the basics here in the Mill 3-Axis Pro for the roughing here, and then in the finish operations, I'm going to cover all of the Mill 3-Axis premium features here in just a couple minutes. So next we get to our tool page. I'm going to go with I'm just going to type in the numbers here. Let's go 3/4. And corner radius, let's go with 0. I'm going to scroll down to the bottom, and we have our feeds and speeds. RPM is about 2,500 revolutions per minute. Cutting feed rate is about 60 inches per minute. Plunge feed rate is about 30 inches per minute. And that is found, these numbers are set based on that cast aluminum that I set for my material in the material library. Next page, we have our different cut patterns. So you can see by default, it sets this adaptive roughing. That's because I have that setting saved in my advanced rough. Up at the top, there's a save icon right here. And I can save any kind of settings if I'm always doing a certain depth of cut, always setting a certain step over here. I can save that setting so every time I go into my advanced rough, now the depth of cut is 200 and the step over is 100 thou. All right, and then I scroll down. And allowance is where I'm setting 15 thou along the side walls of the part here to leave 15 thou for the finish pass to clean up all these areas. Next page, if I want to plunge, ramp, or spiral down into the material into the stock, I'm going to uncheck this box center cutting tool because I can tell the software with that option, if I turn off center cutting tool, I can use the side of the tool to enter into the stock. So it's going to come down to that 200 thou depth of cut here with the tool, and then it's going to move in with the side of the tool entering into the stock like this, giving me this side roughing option. Next page, options like rest roughing is where I can tell the software if I used a larger tool before this roughing operation, I can tell the software the previous tool that I used, and it will calculate any areas the previous tool couldn't fit into and calculate just that tool path for us. So essentially it would start right where we left off from the previous operation and avoid any air cutting. We have a machine flatlands option, so it will machine any flat areas on the part. I don't have any on this part, so I'm just going to leave that blank. Next page, linking for each step over. Our gouge check page to make sure the tool doesn't gouge into the tool or the tool holder doesn't gouge into our workpiece. I have a page for the fixture also to make sure there's no collisions with the Kurt vise and with the soft jaws here. We'll look at that after I hit compute. After my gouge check page, we have advanced feed rates, where I have a radial chip thinning option, an adaptive feed rate to keep a constant chip load so that if I get into corners like this, it'll slow down in the corners here. And MDI stands for manual direct input. If there was any G code I wanted to enter manually, I could go before or after the operation, add a command in here. Usually I just click on raw text. So let's do that. I'm going to go to after operation. I'm going to click on the drop down for the commands, and I'm going to go to raw text. And then I can enter anything I want here. Let's say I type in M01. So there will be a stop command after the roughing operation in the G code because I manually entered it. If I click on comment, then there would be a parentheses before and after to comment anything out. All right, and I'm going to hit compute. Now it's going to take a few seconds to compute because I'm actually just sort of going over all of these milling operations, just going step by step, starting from scratch to let everybody see how I would go step by step with these milling operations. And again, if you're viewing it live, the Google Drive link is in the comments section here. So you can click on that Google Drive link, download the file, and be able to follow along here. So we've got our toolpath here in green of the advanced rough. I can backplot an operation by going to advanced rough under the CAM tree, right click on it, and the fifth option down from the top is backplot. I can click on that, and I can step through and see the current tool location. So if I post the G code, I could see the G code based on my current tool location over here, and just step through and see, all right, I'm starting at my 200 thousandths depth of cut, and then I'm using the side of the tool to enter into the stock and rough things out from there. All right. So there's our advanced rough that we used Mill 3X's Pro for. Now we're going on to the Mill 3X's Premium. These are our surface-based toolpaths. So they're more for finish operations to follow along any surfaces, any sort of, I don't know, we call it like inorganic shapes. Like you can see these kinds of surfaces right here to be able to make sure that we're getting the same surface finish from top to bottom with this part file here. All right, so I'm going to right-click on Machine Setup 1, and the Mill 3X's Premium operations are found below Mill 3-axis, below Mill 4-axis Rotary, the next one down, Mill Multi-axis. Sort of a brief history with the Mill 3X's Premium is it was only included in the multi-axis licensing with BobCAD. We used to not have Mill 3-axis Premium, or it used to be unlocked when you upgraded to 4-axis or 5-axis. But some customers that don't have a 4 or 5-axis machine and want to use these premium toolpaths, well, now it's unlocked in the Mill 3-axis Premium functionality, and is still here under the Mill Multi-axis. And the 4 and 5-axis machining operations are included here, but if you don't have 4 or 5-axis on your license, then you won't have the wireframe toolpath, for example, where the tool can tilt at a certain angle as it does a profile like this. Multi-axis machining is 4 or 5-axis roughing here. Swarf machining, following along any sidewalls here, tilting the tool. Multi-blade is in the 5-axis Premium for impellers. Port machining is in the 5-axis Premium for porting. And turn milling is in the 4-axis for basically turning down the stock, but with a milling tool to rough things out pretty quickly there. Now, in the 3-axis Premium, we have deburring. So this could be in 3-axis, where you can use a ball end mill, a chamfer tool, or you can use a lollipop tool to do an undercut like this on this sharp edge along the corner here. Then down at the bottom, in the Mill 3-axis Premium, we also have all of these surface-based toolpaths as well. Move the camera a little bit there. All right, so the surface-based toolpaths, the first one here is parallel cuts. I almost never use this one, but it's if you want to go down or across any surfaces. This is usually used for 4 or 5-axis machining so that the tool can stay normal to the surface as it cuts across like this. This is the first one I'm going to do, cut along curve, and then we'll cover the other ones after this. So I'm going to select cuts along curve first, and I'm going to show you the geometry selection for the toolpath here. So I select cuts along curve, go to my next page. It's going to ask my work offset number. Next page, it's going to ask for my tool. I'm going to go with a 1/4 inch ball end mill. And then my next page, opening the parameters. This is sort of like the advanced user interface that I covered in the Mill 3-axis Pro. So when I click on open parameters, you'll see very similar options like setting the step over Or if I want to calculate the step over based on my desired cusp height or my desired scallop height, I can type in the cusp height here of, let's say, 1 thou. If I type in 1 thou, it will calculate the step over to keep that constant tolerance level all the way down the part that I'm selecting here. And what I'm selecting for the finish operation here for my geometry is right up at the top here, the lead curve and the drive surfaces. So let's click on drive surface first. And I'm clicking on these two surfaces right here. And then I click OK. And then lead curve, I'm just selecting this edge right here in the center. It's taking a second to load again here. I think I've got some part files that are bogging it down, the information. Okay. Good. All right, so my geometry, I'm selecting the edge right here as my lead curve. And the toolpath will go perpendicular to this edge back and forth like this here across the surfaces that I've selected. All right, I'll click OK. Down at the bottom, we have our cutting method. One way is one directional cutting, zigzag back and forth, and we also have a spiral option. But I'm going to select zigzag here. Next page is tool axis control. If you only have 3 axis on your license, then it's only going to be 3 axis here. But you also have the option for 4 or 5 axis machining, and you can select your rotary axes here as well. Next page, we have gouge check. So again, I can select my tool, the arbor, the holder, and make sure the tool does not gouge into the workpiece. We have linking for each step over, roughing tab up at the top. I can click on depth cuts as an example, where we have a roughing option here where I can set the number of roughing passes, how far they're going to be spaced out, and the number of finish passes and how far they're going to be spaced out. All right, and then the last page, utility. There's some miscellaneous options like setting the feed rate for your first cut, your rapid rate, and different settings like that. All right, so I'm going to hit OK. And then my last page, if I go to the next page again, it's just going to be MDI for manual direct input if I want to add any G-code manually. I'm not going to do anything on this page. I'm just going to hit compute. I'm going to save my progress here. And we'll take a look at, let's take a look at the back plot first, and then we'll take a look at simulation. So I'm going to right-click on Cuts Along Curve and go to Back Plot and hit play. And I can see it run across here. And I'm seeing a lot of linking moves right here, and towards the end here, a lot of linking moves. So what's that all about? It's trying to, as it goes across to step over here, it's gonna, the linking is retracting to the clearance plane, moving across, and then coming back down along the edges of the surfaces. I don't want that. I want it to follow along like I have here in blue, these stepping over. So I'm going to close out a backplot. This is where you can change the linking moves here. You can right-click on the feature, go to Edit, and then go to Parameters and open Parameters. And then that is under the link page up at the top. And you can see like the first entry move and the last entry move, we want to leave those as retracting to the clearance area and approach from the clearance area. So every time you do a tool change, it's starting from the clearance plane. But down here, retract to clearance area under gaps along cut and links between slice. I'm going to change the retract to clearance area to direct. So these last 4 options are all going to be direct, 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 and direct. And then I'm going to click OK. And then I'm going to recompute the toolpath. And those retract moves to the clearance plane are all going to be removed except for the 2 for the entry point and the exit point here. All right. I'm going to save my progress. I tend to save often in case the software program or the computer crashes or you lose power or whatever it is there. A couple other things before I get into simulation. I can extend the toolpath out past the surfaces here. That's sometimes really useful, so I don't have to extend the surface, make the geometry to go out to here. I can right-click on the feature, edit, go to parameters, open parameters, and about halfway down the page, there's a checkbox for extend and trim. So I can trim the toolpath back with a negative number here, or extend it out with a positive number. You could do percent of tool diameter. So if you do 50% of the tool, it'll move over 1/8 of an inch. I like just typing in the value, so I can just type in, let's say, 200 on one side and 200 on the other side. These are tangential extensions. So when I click OK, and compute, it'll extend tangentially here. And then these are our side extensions. So if I want to start a little bit back this way and then end the toolpath a little bit further out, that would be under side extensions. Under extend and trim, side extensions, I'm going to go 200 in both directions here as well. And compute. There we go. There's an extra 200 past the surfaces in both directions there. All right, I'm going to save our progress, and then we'll take a look at our simulation and see how far we've gotten. We've just done the top two surfaces. We're going to go through some more 3-axis premium operations to follow along the sidewalls here, get down the domed surface, and those kinds of options there. So I'm going to click Start Simulation up at the top. We'll take a look at the roughing operation. And up at the top, it gives me my estimated cycle time. It says it will take about 22 minutes and 40 seconds. And I can turn off the toolpath so I can see it go back and forth. I can, what else? If you have Machine Simulation Pro on your license, you can change from workpiece stock to machine. And look at this. Oh my gosh, the stock somehow is inside of the table. And so that is why when I hit run, I get a red tool when it's machining the stock because it's running into the table here. So I'm going to fix that first. Let's close out of simulation. And this is how to fix that. I can right-click on Machine Setup 1 in the milling job and go to Edit. And down at the very bottom, we have this option, Work Offset XYZ. So I'm shifting this up at least the amount of the stock so that the machine setup right here, which is normally starting at the top of the table, is going to shift up so that the stock is above the table as well. I actually want to shift it up even further because I want the Kurt Weiss and the soft jaws and everything to be above the table as well. So I'm going to right-click anywhere here in the CAD workspace, and I can go to Entity Summary. And it's telling me how far down I am in Z with my solid model. 4.902 inches. I'm gonna set it to 5 inches. So in Work Offset XYZ, in Z, I'm just going to type in 5. And this shifts the machine setup in the simulation so that the stock and the Kurt Weiss will be showing out of the table. but it only changes the coordinates for simulation. It doesn't change anything for the G code here in 3-axis. So I'm only seeing my stock in the simulation so far. I want to select my fixture. So that's found under Machine Setup 1. We have fixture. I can double click on that, and I can select everything except for the solid model and click OK. So now when I go into simulation, I'll see my Kurt vise, my soft draws for the fixture, I'll see my stock, and I can see how much material is remaining for the part file here. For some reason, I didn't get my Kurt vise all the way up above the table, and I know why now. Let's close out of simulation. That's because when I right click and 1, 2, 3, 4, 5, 6, 7 down, I go to Entity Summary. This is in relation to my CAD origin location, which is down here, but I need to know how far I need to shift it up from my machine setup up here. So I'm going to go with about 8.5 inches instead of 5. So let's find where that is again in the CAM tree. I'm going to right click on Machine Setup 1, go to Edit, and at the very bottom of the page, I'm going to change the work offset XYZ from 5 to 8.5. Now this should look a little bit better in my simulation here. All right, that's looking better. I'm going to hit run. Now there shouldn't be any more red of the tool and of the table. And you can see with this BC3X mill, this is all modeled with STL files. So the table moves in X and Y, and then the tool comes down in Z here. The spindle comes down. So we can see that's a lot of material remaining right here for a finish pass. I want to remove a lot of this material in the roughing. Then we'll get into the Mill 3-Axis Premium. I can't remember if I went over this in 3-Axis Pro last time, but we'll go over it again if I already did. I'm going to right-click on Feature 3-Axis in the Machine Setup page for my Advanced Rough. I'm going to right-click on Feature 3-Axis, go to Edit, and under Patterns and Parameters, I'm going to scroll down where I have my depth of cut and my step over, and then I'm going to check this box Number of Intermediate Steps, and I'm going to click on that checkbox, and I'm going to type in 2 for number of intermediate steps, and then I'm going to hit Compute again. Then we'll simulate this. And I'll try to explain what the number of intermediate steps does here in the roughing operation. So it's going to get all the way down to the bottom. And then once it does, it's going to come back up. And at each step here of 200 thousandths, it's going to create 2 more passes at this depth and then come back up at this depth. And then it's going to do 2 more number of intermediate steps from here. It's going to cut here and cut here, as we see right here. So there's the first one and then the second one. So the stair stepping it cuts it into 2 more steps. So I guess it'll do like, what would that be like? It would be like 2/3. So like 660 and then another 660 in between, something like that. Because this is 200 and then in between there's a third and then another third there. If that makes sense. But once it gets to the very top, you can see how much more material is being removed. If you remember, the cycle time was about 22 minutes last time, and this time it's 28 minutes. So it's just taken an extra 6 minutes to remove all the rest of this material, and that should be a lot less material for the finish pass to cover on top there. It's not too bad. And then again, you saw the roughing option for this cuts along curve if you want to do a couple of depth cuts here instead of just the one pass back and forth. All right, so we did the top surfaces here with cuts along curve, and then we're going to start from there and work our way down with the next option down in our surface-based toolpaths in Mill 3-axis Premium. Sorry, let me get this out of the way. All right, so I'm going to right-click on Machine Setup 1, and I'm going to Mill Multi-Axis, which is where all of our surface-based toolpaths are located. We just went over cuts along curve. The next one we're going to go over is the next one down, morph between two curves. And you can see these sort of shapes, these weird shapes like this hourglass shape on top. The surface-based toolpath follows along the surface. Morph between two curves starts at this orange edge here. That would be the first pass, and then it'll step over across, and then the last pass will be the second orange edge right here. And it morphs the toolpath to keep a constant step over all the way across the surface there. And we'll see how that's defined on the next page. We've got our work offset number. Next page, we have our tool. I'm going to use a 1/4-inch ball end mill again. Next page, we're going to open our parameters. And similar to the cuts along curve, I'm going to select my drive surfaces first. And I'm just going to select all of these surfaces going around. And let's do this. Yeah, let's just start with that. And so I've selected all the radiuses here, and I click OK. And then first edge curves, I'm going to select the edges around here. Auto connection should work for me with this. Maybe not. Thought it would work for the tangency here, but wishful thinking. I'm selecting all of the top edges of my surfaces like this going around. I know it's a little hard to see with the toolpath showing for my cuts along curve. But I'm selecting all the edges going around here on top, and then my second edge curves would be all of these edges going down from here. This one and this one. And then I click OK. So I did my drive surfaces. First edge curves where the toolpath is going to start. Second edge curves where the toolpath is going to end. And we have our trim and extend option here. We have one-way cutting is fine. It's going to step over as it rotates around, sort of. And then, again, my step over, I don't know, let's go 20th out for the step over. Tool axis control is 3-axis. Gauss check, I don't need to do anything there, but the next page, linking, again, I'm going to change it to direct for gaps along cut and direct for links between slice. And then I'll click OK and then compute. All right, so there's the toolpath for that one. Taking a minute to load here. While that's computing, let me know if you guys have any questions so far in our Mill 3-axis premium toolpaths. So far, we've gone over a few of the basics there: deburring, parallel cuts, cuts along curve, morph between two curves. I'm going to do one more morph between two curves, and then we'll do parallel to multiple curves next. So I'm going to do... No, you know what? I'm going to go off script here. Let's change morph between two curves to parallel to multiple curves for the next one. You can see this example here. It starts with a toolpath as the edges I first select, and then it will create an array of the toolpath outward. So I'm going to see how this one looks here. I'm going to select my tool as my 1/4" ball end mill. Next page, open parameters. My drive surfaces is usually the one that I pick first. I'm going to pick all of these going around here. From just below the radius here, just below this fillet, I'm selecting all the radiuses below that, all the way around here. And then I click OK. Edge curves is just going to be these edges all the way around. So I'm starting the toolpath around these edges here. This one, and this one, and this one. Click OK. Step over, let's go 20 again. One directional cutting is fine. Only other changes I'm making here is going to tool axis control, make it 3-axis, and go to link and make it direct for gaps along cut and direct for links between slice. So if you have the 3-axis mill functionality in your software program, you can see a lot of the settings that are really useful for you to be able to to get the best kinds of toolpath in the surface-based toolpaths here. The direct step over option, being able to, what else? The direct step over, you've got the trim and extend option, your cusp height, so that it sets a step over based on your cusp height here, and tool axis control is going to be 3-axis for you. Yeah, I don't necessarily like how the toolpath looks, but we can backplot it. We'll see how it looks here. But at least we can see the difference between, like, oh, it even starts from the bottom, which I don't like either. We can set a start point so that it starts at the top rather than starting at the bottom. But what I'd like to do is just change this to morph between two curves. So I'm going to right-click on parallel to multiple curves, edit, and I'm going to change it from parallel to morph between two curves. I'm going to do the parallel from this edge outward from there. So let's start with morph between two curves. My drive surfaces are going to be the same. My first edge curves are going to be the edges that I left off with from the previous morph between two curves. Click OK. And then my second edge curves would be down at the bottom here. This is going to give us a much better toolpath for this one. Because it's going to start right where we start here, and it's going to end at this edge right here. And that should be all I need to change, is my geometry here, and then compute. And you can see with this one, instead of just doing an array of the toolpath and setting your specific step over, you can see there's a smaller step over as it gets down into the bottom radius here than it does up at the top. It gives us a variable step over rate, similar to like the planar toolpath, so that it's going down and giving us the same surface finish all the way down. All right, next I'm going to do cuts along curve for this one here. I'm going to right-click on Machine Setup 1, mill multi-axis. Let's go parallel to multiple curves. We can look at the other ones here for a second. Project curves is just like the 3-axis Pro project curves. This is in here more for 4 or 5-axis milling so that the tool will stay normal to the surface as it does a 3D engraving of any 2D wireframe here. Morph between two surfaces is just like the morph between two curves, but you're selecting two surfaces if you're going down into a channel like this so you can avoid any gouging. Parallel to surface is just like parallel to multiple curves, but again, you're selecting surfaces so that you don't gouge into any surfaces, and then it creates an array of the tool path from that geometry. And we have flow line for any undercuts. You can select a lollipop tool and be able to do an undercut like this with the flow line. If we look at that for a second, all you're doing is basically selecting a lollipop tool and then selecting a surface that you're going to do the flow line toolpath on. And it's easy as that. All the other options are the same, extending the toolpath, setting the direction of the cut, your step over, things like that. All right, so I'm doing parallel to multiple curves. This one should look a little bit better on this one. If I go to open parameters, my drive surface is going to be this one. And my edge curves are going to be everything on top of the drive surface that I've selected, all of these edges going around it. And click OK. Step over, we'll do 20 again. One directional cutting, 3-axis, and direct step over. This is one that a lot of people overlook or don't see right away. That's a good one to look at, to be like, oh, that's where I can set a direct step over linking. Looks a lot better that way. I think I can just, because it's trying to start from the bottom again, it looks like, and work its way up. So I'm going to go to open parameters and try cut order from center away. Let's try that. No, it's still, isn't there like a flip option? Standard. Flip step over. Let's try that. Yeah, that's the easiest way of just flipping it top to bottom. All right. And then, like, say, for example, you've just got like one surface like this you want to focus on. My go-to is morph between two curves. So I can go to mill multi-axis, morph between two curves. I'll use this like 90% of the time. About 10% of the time, I'll use parallel to multiple curves, and I almost never use the other one. Sometimes I'll use cuts along curve, like the first example. All right, 1/4-inch ball end mill, open parameters, drive surface. If I want to focus on just one individual surface like this, I'll show you the geometry selection here, just selecting this surface. Click OK. First edge curves. So if I want to go back and forth and start here on this edge, that would be my first edge curves. And then second edge curves would be down at the bottom. Again, set my step over. Let's go 10 for this one. 3-axis and direct step over here and compute. So you can see the tool path going back and forth. I want to zigzag back and forth. You can see the tool path going back and forth like this. But if I want to go up and down, starting here across, then I just go to my parameters page. First edge curve is where I want to start. So I'm going to change the geometry to here. And then second edge curves is where I'm ending the tool path, which is going to be back here. And then compute. So it's as easy as that to select which direction of the cut across the surface you want to go. And with the surface-based toolpaths, it uses all of the radius of the tool as it follows along the surface. This is showing you that it's a surface-based toolpath. It's not just using the tip of the tool. I mean, it's using the tip of the tool for the G-code, but it is going to use the full radius of the tool here as it goes along the surface. All right, so I'm going to close out of that. I'm going to save my progress and then take a look at our simulation here. A couple other cool things in simulation. I think I went over in the 3-axis Pro, but we'll go over it again here in the 3-axis Premium. I'm going to hit Start Simulation up at the top. Again, we went over the cycle time up at the top. Now it's saying it'll take about 47 minutes for my roughing here. It's making me a little dizzy, so I'm going to turn off the machine for now. So it'll fix the view on the stock and the workpiece instead. So here's a 3-axis roughing. Then we get to the first 3-axis premium toolpath, cuts along curve. Again, I just selected the top 2 surfaces here, and I selected this center edge on top, and the toolpath goes perpendicular to that lead edge. Then I selected the surfaces here for the fillet on top, and that was with morph between 2 curves. My second morph between 2 curves operation was from the bottom of the fillet down to the bottom radius down here. And then parallel to multiple curves, where it's just going to keep that toolpath around the geometry of the radius here and just step over with the same toolpath shape there. And for some reason, what was that last one? That was the parallel to multiple curves. That was weird. Let me see why that went all the way down in there. Oh, that was the direct step over. Okay, that's interesting. What do I want for the step over then? Maybe I do need to do. This is a great example here. You can see the direct step over here in blue is just wiping out the part. So if I go to parameters, linking, this is a great example of showing where direct isn't great. I could change it from clearance to either feed or rapid. Let's try feed for both of those. No, because it's only going to the feed plane 100 above the part, so it needs to be clearance. And we are seeing why it is defaulted to retract to clearance area here. There we go. So if it needs to retract from one side to the other with this morph between, parallel to multiple curves, it's going to retract to the clearance plane and come back up. Ooh, now look at this. It is just hitting right on top here, it looks like. So here's where I can find that clearance plane. I'm going to right-click on the feature and edit. It's under Parameters. Go to Open Parameters. Go to Link. And down at the bottom, we can click on Clearance Area. And this is automatic and automatic. Interesting. I'm going to change it to plane. If I was in 4-axis, it would be cylinder, or if it was 5-axis, it'd be sphere. But it's just a plane in 3-axis here. And let's go incremental height of 6. That should work for us. Oh, maybe not. I'll add 1 inch to that. So again, we go to the link page up at the top, clearance area button down at the bottom left, and change the incremental height to 7. What is that in relation to, I wonder? Because it's not raising up at all. All right, let me go back to the link page. Maybe retract distances, rapid entry, air move safety, rapid distance in tool plane. I would think it would be plane, direction would be Z. I don't think it'd be either of these. Height, user defined. Let's go 7. Whoa, that's way too high now. So now we can go to parameters, open parameters, link. I knew it was something here in the clearance area, so I click on clearance area. User defined here. Let's go the height of the, well, I think I just need to put 1 because it's based on the machine setup. So I just want to go 1 inch above the top of the stock there. That's looking better. And that was zigzag? No, that's one directional cutting. Okay. If I went zigzag, it'd probably be less moves there. A little bit. Anyway, I want to focus on the simulation now. So up at the top, I go to Start Simulation. You can see some of the settings you can change in the Mill 3-axis Premium to get the exact toolpath that you want there. I'm going to click on Next Op so I can skip the roughing operation. We'll look at the surface-based toolpaths, cuts along curve, then morph between 2 curves going down the surfaces here, then parallel to multiple curves from here across. And once everything is done, I can go over to the right-hand side, and under this Analysis tab, on the drop-down, I can click on Deviation, the 4th option down, and hit Refresh. It will show me different colors on the stock depending on how much material is remaining. So everything here in green is showing me everything is cut to size with a cut tolerance of plus or minus 8 thou. We didn't get the sidewalls. Here in light blue, there's anywhere between 8 and 26 thou remaining. If you remember in the roughing, I left 15 thou as an allowance. So here's our 15 thou allowance in light blue. And then the dark blue from here down, I need to flip it over and oops. I need to flip it over and face off the bottom side of the part here. Everything in blue is anywhere between 64 thou or more remaining on the bottom of the part there. But this is a great verification tool in simulation. Again, that's found down at the bottom, this Analysis tab. And then in the drop-down, you'll select Deviation and hit Refresh. And it shows you the different colors to make sure that everything is cut to size before we run it on the machine. If I have any kind of blue, maybe I forgot to do this finish operation, and I'm like, oh yeah, there's an extra 15 thou here. Then I would close out of simulation and run a 3-axis finish operation down the sidewalls here. Probably a morph between 2 curves. That's what I usually go with to start. All right, so I'm going to save my part file. And if you guys have any questions, I'll hold back for a couple minutes and answer any questions that you have in the Q&A section here. I want to thank everybody for viewing the live event today. We went over Mill 3-axis Premium, some of the surface-based toolpaths here to give you a better surface finish on your part and it also will take less time, less cycle time at the machine, and you have more options to manipulate the toolpath. Some settings here under parameters, like selecting how you want to start the toolpath with your first edge that you're starting your toolpath on. You can set your extend and trim options. So if you need to trim the toolpath back a little bit, you can set a negative number here. Or if you want to go overlap past the surfaces a little bit, you can set a positive number to go past it with your extend and trim options. You can set your step over, or you can calculate the step over based on your desired cut height. And we also have a roughing option if you want to do it in a couple of depth cuts here, a couple of passes. You can set your number of passes and how far they're going to be spaced out for your roughing passes here. But yeah, all in all, a lot of good settings to be able to manipulate your toolpath to exactly how you need it to. I think once you get the surface-based toolpaths down, understanding them and being able to manipulate them a little more easily, it'll take less time to compute the toolpath in BobCAD, and will also take less cycle time at the machine. All right, cool. I don't see any questions or comments, concerns. So I want to thank everybody again for viewing the live event today, and we hope to see you in the next one. It's going to be March 18th at 1 p.m. Eastern Time. All right, thanks everybody. Have a great day. See ya.